So in this video, we're going to look at calculating an improper integral that has two infinite limits. So what we do in this case is we actually split this into two improper integrals. We can split it up any place in between negative infinity and infinity that we want. Typically 0 is the easiest, so that's what we're going to do. So my first integral is going to go from negative infinity up to 0 dx over x squared plus 25, and then we're going to go from 0 to infinity of dx over x squared plus 25. The nice thing is the antiderivative is the same for both, so once we get one of them, we'll have both. And now we turn them into proper integrals with a limit. So the limit as a goes to negative infinity, the antiderivative from a to 0 of dx over x squared plus 25, plus the limit as b goes to infinity from 0 to b of dx over x squared plus 25. Okay, now let's talk about finding the antiderivative of dx over x squared plus 25. So one way we might decide to do this is we can actually do it as a u substitution. And what we'll want to do, you can see that this has a form of an arctan. We would like this to be a 1 here. So what we're going to do is divide the numerator and denominator by 1/25. So let's do this on some scratch paper here, and then we'll find the antiderivative and we'll plug that in. So got the antiderivative of dx over x squared plus 25. We're going to multiply 1/25 on top and on bottom. We can do that because 1/25 over 1/25 is just 1. What that does for us, we're going to end up with a 1/25 out front. I'm just pulling this one right out front. Dx. Here we're going to have an x squared over 25 plus 1, because, careful, this gets missed a lot. This has to get distributed to both. What we're going to do now is we're going to keep the 1/25 out front. We have the dx on top. We're going to rewrite this as x over 5 squared plus 1. And there's our u substitution. U is going to equal x over 5. Therefore, du is 1/5 dx. Well, that of course means I need a 1/5 here, so I need to multiply by a 5 out here. Alright, so this is going to simplify. 5 over 25 is 1/5. The 1/5 dx is exactly du. This part here is exactly du. And this becomes u squared plus 1. And now we can see that this is in fact an arctan. So we get 1/5 arctan of u plus c. We don't really need the plus c for our purposes, but to be accurate, we'll put plus c. And now we have to sub back in the x over 5. So 1/5 arctan of x over 5 plus c. There's our antiderivative. So combining that with our work up here, we're going to have the limit as a goes to negative infinity of 1/5 arctan of x over 5, and this one's going to go from a to 0, plus the limit as b goes to infinity of 1/5 arctan of x over 5, let's rewrite that, x over 5, and here x is going to go from 0 to b. So we don't need this anymore, so let's move that out of the way, and we're going to work from here. Now we need to plug in our limits. So we have the limit as a goes to negative infinity, 1/5 arctan of 0 over 5, so it's going to be arctan of 0 minus arctan of a over 5 for this first one, plus limit as b goes to infinity of 1/5, arctan of b minus arctan of 0, b over 5, too many errors, I'll slow down, arctan of 0. Now, one of the nice things, arctan of 0 is exactly that, it's 0. So those go away. Now, the graph of arctan, that's an interesting one. It looks like this and has two horizontal asymptotes, one at negative pi over 2 and one at pi over 2. And you can see this from a graphing calculator, any graphing system you want to take a look at. Now what that means for us, as a goes to negative infinity, so as the argument of arctan goes to negative infinity, it goes to negative pi over 2. So we get 1/5 times 0 minus a negative pi over 2. It's going to be very similar as we go to positive infinity. We're going to, with 1/5, it's going to go to pi over 2 minus 0. And this is going to give us end up giving us our final answer. What we're going to end up with, negative and times negative is a positive. So we get pi over 10 plus pi over 10, which is 2 pi over 10 or pi over 5. So this guy converges to pi over 5.